Thank you, Chinmay. Thank you all. So my name is Sri, and I'm representing my group Team Torpedo. I'm going to explain my journey, how we build an AUV. So initially, okay, yeah. So about Team Torpedo, it's we are actually I'm studying in a school called PSB Academy and pursuing my bachelor's in robotics and AI under University of Hertfordshire. So the team is 6 students and 1 lecturer, and I am the team lead. And we have 2 mechanical designers, 2 electronics and computing engineers, and 1 person who handles logistics and media. So the team goal is to study and develop a versatile autonomous vehicle which focus on water explorations, both surface and underwater. So the reason why we choose to build an AUV, like mostly people build robots which works in the lands and surface. So we find curious to see a robot which can go underwater and explore the sea and get some data in under the oceans or under, especially it feels excited to see in a different environment. So only we choose to build a AUV, a robo which can go underwater and find out any simpler, low-cost solutions available in making a robot, or we can. Okay, totally. The idea is it's totally different, and we want to explore a domain which is unexplored. So that's what we choose an AUV, and it's excited idea. The idea is looking very exciting and very cool to see the explore the world of underwater. And if we find any slow cost, simple solution which makes engineer life easy, we can try to explore. So that's what our team was focused. And if we able to bring out a good solution, maybe if it under good optimal price, we can write paper under it. So that's what these are the reasons we choose to build an AUV, make an AUV. So this is the current form, and okay. So this is the current stage of an AUV which we designed it, and it's actually has it. And this is the first attempt. We took all the things from our schools and we built it. Nothing was purchased outside unless the battery and the thrusters and everything which was we built it in the school itself. So about the AUV, so it took 6 months to build an AUV, which typically works. And this is the 4th design revision. And we have tested almost 20 trials in water. There is no physical damage over here. So the AUV weighs 17 kg in air, and its dimension is 62, 61, 24, and it has 5 degrees of freedom, which is, as you see, the AUV has 5 motors and it has 5 degrees of freedom. It doesn't has a freedom of degree in surge it has, but yeah, heave surge, and okay, it doesn't have a one-off movement, and we haven't figured out. It's a vertical and okay, the vertical downwards movement is known as Q and heave, and surge is like the forward motion.
In the marine world,
yeah,
it can't go side to side.
Yeah, it doesn't go side to side because it has only 5 degrees of freedom. And we haven't actually measured the top speed, and it's powered with a LiPo battery, a single battery, which is 11 volts. And okay, the control system is totally customized, and it has 2 sensors. It doesn't has a camera on board, and it has a computing device, which is NVIDIA Jetson Nano, to do the computing. And this is the video. Just yeah, we capture. It's completely depth reckoning. There is no sensors to capture its motion, and we right now we have a kill switch which turns off the thrusters and it basically comes out. That is the. So there's basically no intelligence in this mission. It when you turn on the kill switch, it basically goes down, and when you remove the kill switch, it comes out, and it's completely dead reckoning. Okay, so we have some goals. First thing is we as Chinmay was explaining, he's a part of an AUV committee. So there's a competition where people will be participating in the AUV event and they'll be expressing their robos, AUVs. So we also want to participate in them, not to win, but we want to see what is the what ways we can learn to build AUV. There are very difficult situations we came across in building in Robo. So the journey has taught us many things from mechanical design, electrical design and insulations, and many other things in computing also. So we want to build an AUV which just barely qualifies to the finals. And yeah, for qualifying finals also, we need some kind of improvements in the current AUV. So we are focusing towards it. And the future goal of our AUVs is to publish some papers regarding AUV designs, which can be an optimal one or which can be a low-cost sustainable one. Regarding that, we want to publish some papers, and we also want to participate in RoboSub, which is an international AUV competition where worldwide people used to participate in them. So we want to give a try in the RoboSub also and participate in next SAUVC 2026. So future plans of our current AUVs, we want to add a visual odometry. So as basically everybody knows about what is a odometry sensor. So odometry is which typically it's a robo. Okay, as a person is able to understand how he can go forward, backward, reverse, front, and right. But for a robo, for a machine, it has to capture the sensors, and it actually need to perceive some inputs to know whether it is going front, whether it's going right, whether it's going left. To do that, our team will be using cameras to know whether it's going front, the AV is going front, or the AV is going left, right. Capture these data and make a pattern to it. And also we will be a path planner also we are planning to implement in the current AUV using Doppler velocity logs. So these are the future plans which we will be our team is currently like looking to implement it. And the challenges is like while making this, we okay, it was making a box. It was not an easy thing. That especially making it waterproof. It was like just a pain. We for the enclosure we have designed 3 times, and our 2 designs were completely failed. And without the time limits, we went for an airtight enclosure, which I purchased in Mustafa for $30, which was the cheapest one. Which was the cheapest one, and it was also having some issues. But yeah, we want to make the enclosure way better. And this is from actually I have an IMU in the AUV, but with that I was currently facing an issue with this to test whether the AUV is able to get the initial measurement data about its movements. So basically I made a simple picture with this, which is 10C board, and I'm able to capture the data, how it is being tilted, how it's being oriented. So with this data, AUV can see, okay, it is going forward, or it is being tilted, it's having a pitch over, or it's having a roll too much. So I need to control the thrusters. So this is what I was using Blender to simulate this kind of simulations to understand how AUV is able to go in the water, how it is being behaved under water. Based on that, the thrusters will be activated and it will be stabilizing the AUV in underwater. So in this, the challenge was when it was doing its yaw movement, it was not able to get the data precisely because it was having some noises. We use complementary filters to adjust the yaw movement, but also due to some noises, it was not able to give data very precisely. So this is the challenges still we are facing, and we are trying to correct it, but we haven't done yet. And about the last thing.
You can move the zoom thingy down. So you can see it.
Okay. Yeah. Okay. So these are the two challenges we have faced, and the special thanks. There are many people I need to thank while doing this project, especially my mom, because every time she asks me, when is your project going to complete? I say like my project is getting evolved bigger and bigger. It is not going to end at the moment. And next thing is I need to thank my dad because he is the one, as a mechanical engineer, he gave a special weights which able to make the AUV to be naturally buoyant, and my team who were helping me in each and every task, maybe in the logistic area, in electrical and in the computation, they were helping me in doing the various activities, even in the building the website also. And last, especially the Hackware team and people like Chinmay, who encouraged me to participate as a volunteer for the SAUBC 2024. And Mr. Adnan sir, he only gave me 10C boards, which I used in the AUV for capturing the data. Still now it is being used, and still I want to thank everybody who helped me in some or the other. They helped me to make the AUV into a success mode, and I don't want to stop from here. I want to still work on this project even more and more, and want to write some papers or some new innovative ideas which I'll be coming across while doing this project even for the heights. Thank you all. Yeah. No, that's our future plan. Right now, we don't have any kind of in the future. We are going to implement in the future. Right now, there's no sonar. Yeah, actually, it's the power of the thrusters. It was able to give the force, and due to the thrusters force, it was able to go inside it. And we maintained a natural weight of 17 kgs. There's calculation which I will show in the later part of in the end of during the talk. I'll just show that there's some calculation, buoyancy calculation, which we calculated it, and it's just the density. We need to find the density of the AUV, and we should match the density of water. So yeah. So if you try to match the density of your water density to AUV density, it will be natural buoyant. So you need like little bit force. They'll call it as a buoyant force, which will be given by your thrusters. So due to the thrusters force, it can go down to the various height. Yeah. When you turn off the thrusters, it will go up. Yeah. Just the thrusters.
So you mentioned using the cameras for figuring out the
odometry. Yes.
I would think that in the ocean, all the cameras are going to show you a moving. Like what is it that you can see in a camera that can show you if you're moving towards something or from or to the side?
Actually, that one we had random ideas collected and we have kept it on. But I'm also open to get some new ideas. And if you feel free to share some ideas also, we will try to implement it. Because right now the future plans are not fixed yet, because it's under development. We haven't done anything much about it. Right now, there are a few areas where we want to correct in the existing AUV, and future plans is just a plan. So we are open to collect ideas, and we will be like doing some things.
In the ocean, sure, you can't say but in the swimming pool,
you
can say everything.
But I mean, that's over 50.
Yes.
Challenges.
Exactly. If you care about winning, then historically there were teams who actually have done that to great effect.
The question in the chat. And
what sort of coatings or gap fillers did you use to waterproof it? Oh, that's a fantastic one. Thanks.
Okay. So that one, we use this Bamboo Labs printer, and we kept the layer height of 0.2. Due to that capacity, the prints were like it was watertight, and there was no water was seeping inside the layer gaps also, and it was so cool. Maybe I can use epoxy paint to paint up on top of the 3D parts to make it waterproof. But so far the print was quite stable and we were able to use 30-40 times, like 20-30 times. And we were able to get into the MRT also. The print didn't break also, it was quite solid.
Oh, I have a probably very specific question. Like, you would think that either you need to make it waterproof or you could use things that don't mind water. Like, are there such electronic components? Do they exist? Things that you can just put into water?
I'm not sure about that. Maybe I could have figured it out.
Not very commonly, but on this topic, there's a fantastic talk from another such event, but from the US. I think it was one of the one of the Hacker Day conferences about a guy who works for,
Oh, my friend.
a guy who works for one of the oceanographic institutes in the US. Where they specifically try to do this, where they, instead of making everything pressure, basically, if you want to go really deep, you need to build the pressure vessel. They did that way around. They coated the electronics with some kind of a gel, waterproof gel, and they let the pressure go all the way in. So they don't. But then I don't want to spoil the talk, but it's fantastic. He talks about what are the different problems you face if you put silicon under 100, whatever, 2, 3, 4, 10 atmospheres of pressure. Interesting stuff happens. Interesting things happen. But it's a fantastic talk. I'll link to it in the meetup stuff. Yeah, thanks, Sreedhar.